In this chapter, we're going to start learning about the fundamentals of organic reactions. And this chapter is extremely important, and it's one you really want to understand because what we learn here is going to set you up for success in the future chapters where you look at different reactions of the different functional groups. Most organic reactions are going to follow a very simple pattern where we're reacting two things together. We'll say A plus B. And basically what happens is A reacts with B. And we're going to show an arrow going from A to B. And basically what this is a site of high electron density in A reacting with a site of low electron density in B. And these two species are given very special names. So the site of high electron density is what we call the nucleophile. And that's often abbreviated as just Nu. And the site of low electron density is called the electrophile. And we'll often just abbreviate that as E or E+. So what do those terms mean? Well, the electrophile means this species loves electrons, and the nucleophile is providing the electrons. And then the term nucleophile means this species loves the nucleus of an atom, which we know is positively charged. So positive charges, low electron density. We're going to talk much more about the fundamentals of this curved arrow that I drew in blue. But for now, just keep in mind that the tail of the arrow is on the nucleophile. The head of the arrow lands on the electrophile. Let's now apply the principles we learned here to a real reaction. So here we have methyl lithium and chloromethane. And let's start with the methyl lithium. And when you see something like this where you have a carbon bonded to a metal, you can break this up into ions because the metal can be positively charged, the carbon negatively charged. So when you see this, it's often best if we write it as the countercation and the carbon anion, and that carbon has a lone pair. So what you can see with this, because this carbon has this lone pair, this negative charge, that is a site of high electron density. So that will be our nucleophile. Then when we look at the chloromethane, the carbon is bonded to a nonmetal. So we can't break that apart. But what we can do is say that there's a dipole here pointed toward the chlorine. And that means the chlorine's pulling electrons towards itself, and it becomes partially negative. The carbon is therefore partially positive. So I'll just move this down so it's aligned with our nucleophilic carbon. And what we can say about this carbon is that it has low electron density because of the partial positive charge. So it's the electrophile. When you have a nucleophile and electrophile, those two things will react. All right, so don't concern yourself with the lithium cation. That is a spectator ion. So if you have metal cations, don't worry too much about those. We're going to focus on our nucleophile and our electrophile. And what we're going to do is put our pencil down on the lone pair of the nucleophile, because that's our site of high electron density. Draw a curved arrow to the electrophilic atom. Okay, but what's going to happen at this point, and this is something we're going to get into in more detail here in a bit, but this carbon right now has 4 bonds. It has 3 to the hydrogens, 1 to the chlorine. Carbon can't handle any more than 4 bonds. But what we're doing with this arrow is showing a new bond forming to that carbon. So as a new bond forms, another bond must also break. And what breaks is the bond between the carbon and the chlorine. Those electrons leave the carbon and go onto the chlorine as a lone pair. So when we draw the products here, we're going to have the green carbon, or the green methyl group. Its lone pair is forming the bond with the red carbon, red methyl group. And then the chlorine already had 3 lone pairs. In the product, it has a 4th. And a negative charge. And you can think about that kind of hanging out now with the lithium plus that's floating around in the solution. So this is the basic step you're going to see in most organic reactions: a nucleophile reacting with an electrophile. So our next goal is going to be just to identify different types of nucleophiles and electrophiles so we can predict what things are going to react with one another.